Okay, well, good morning, everybody. Welcome to the Center for Global Security Research and the maiden seminar on biotechnology. We're excited to welcome you guys here. It's great to see a great audience and a lot of familiar faces in the biotech world for Livermore. We are starting a new series, and we're going to have a number of different speakers. Gigi Gronvall is our first. We have the pleasure of having her. The purpose of the series and the title of the series is Emerging Biotechnologies. We'll be looking at developing issues and then possible solutions in biotechnology field. As many of you know in this audience, it's a very broad and dynamic area. So we're looking for any input that anybody has. If you can come forward, give us ideas, have comments, please reach out to me. My name is Paris Althaus. My intern who's helping us this winter, Young B. Lim. And then many of you know Don Prosnitz back there. So if you guys have ideas, an old timer can still raise his hand. So today we're bringing on Gigi Gronvall, who is a senior associate at Johns Hopkins. She is a trained immunologist, so she's got some meat to her policies. She spent a lot of time looking at the scientist's role in health security and how it can contribute to the technical response against biological weapons and natural endemic problems, an area that Livermore surely can help with. So her latest book, published last year, 2016, Synthetic Biology, Safety, Security, and the Promise. Quick read. I highly recommend you guys picking it up. It's a great, well-rounded piece, I believe. Her talk today is going to be on safety, security, and the promise of emerging biosciences. So it's all you.
All right. Thank you so much. Oh. Thank you very much for inviting me out here and for coming this morning. I am going to talk about some of the safety and security and competitiveness aspects of a particular area of emerging biosciences. I put that in the title versus synthetic biology, so I had a chance to define it a little bit. All right, so synthetic biology is a relatively new technical area that is only possible because of the convergence of biology, chemistry, advanced computing power. Wait, first I should say that I know, I'm looking in the audience and I know that some of you are very deeply expert in this area. So I am not going to, I want to start for people who are just new to this, so bear with me. This is a pretty new technical area that is basically, there's a lot of different definitions for synthetic biology, but the general aim is to make biology easier to engineer and more useful. And it's confusing because it applies to a field, a technical endeavor in its own right, but it's also, the term synthetic biology also applies to a set of tools that come from synthetic biology, but are now broadly distributed throughout the biological sciences. So you have probably heard of gene synthesis and DNA synthesis and CRISPR. These are tools that are not just useful for synthetic biology people who are studying that particular field, but for biologists of all types who are interested in using these tools. So as a result of synthetic biology work and the tools that come from it, it's bringing about some pretty significant changes in biology and in industries. And I'm going to talk about some of those changes in the industrialization of biology and the personalization of biology. And it's also giving some tools that for public health that just were not possible before. So it's lots of cool things that are coming up. So industrialization. Biology has had a role, it has had its industry for a long time. It's not like there was no agriculture as an industry. Beer and wine are made using biological processes, vaccines, some drugs. But what has changed is that biological techniques are moving into areas that have been traditionally the province of petrochemical engineering or just the harvesting of really intense, difficult harvesting of natural, natural resources. So I'll give you an example with tires. Tires come from rubber trees originally, but there's just no way that you have enough rubber trees to be able to satisfy the worldwide demand for tires. Apparently, there's 1 billion tires born last year. So so most tires are actually made from oil. It takes about 7 gallons of oil to make a tire. And but there are Michelin and Goodyear have partnered with biotech companies to be able to produce tires from a biological process. So right now the market's not favorable to actually produce this put this on the market, but it is now something that can be done where biology can replace the use of oil to make tires. This has already happened in more other areas, creating adhesives, new ways to do mining, the cosmetics, of course, and flavorings like vanilla. Vanilla is another natural resource. It's very difficult to grow these orchids, to be able to produce vanilla beans, and they have to be hand-picked and everything else. So a lot of vanilla is actually made from chemically treated paper pulp, not from the actual bean. So just think about that next time you bite into a vanilla flavored something. But there's a company in Switzerland that is using biological processes to produce vanillin and for a flavoring. And so and they're working on saffron, although I don't think that's been released yet. So this is something that's a little new, and it's big business, and it has the potential to have more distributed manufacturing. It has lots of people are going to make lots of money off of this. They already have, and companies are investing in it, and nations are investing in it because they see this as a way to grow the economy of the future. So on the other end of things, these new tools in synthetic biology are allowing biology to be more personal. So things that you're able to do things that are not going to be the subject of an NIH R01 grant. So things that are important to you but not to anyone else, like figuring out what's in the soil around your house, or whether the sushi that you got is actually as advertised, or whether it was some other fish. Things like that are more possible than, and people can do it themselves. And CRISPR, so the way I describe CRISPR for people who are not familiar with it, it's a little bit like in a Word document when you do search and replace. It's like that, but with genes. So you're able to find particular sequences and replace it with something else. These technologies are pretty cheap. You can order CRISPR kits for less than about $150. For yeast systems, and you can do this at home in your kitchen. And so there's a lot of things that people are able to do. There's a lot of new businesses that can come about as a result of this. The dogs are to remind me that there's a couple of companies that apartment complexes will work with them so that they can type the dogs that live in the complex so they can identify irresponsible owners. If by typing the dogs. Personally, I think it might be a little easier just to put video cameras in places, but apparently there's some deterrent value in getting the type of your dog. And then it also has allowed, so there's the DIY bio movement, the do-it-yourself biology movement, where people can actually use these techniques even if they're amateurs. But there's also the IGEM, International Genetically Engineered Machine Competition, which you might be familiar with the robotics competitions that a lot of undergrads are involved in. It's like that, but with synthetic biology. And these students have a summer to work on genetic engineering of a microorganism and then present it as in a competition. So it started as a class at MIT a little bit over 10 years ago. And now, last year, it had 5,600 participants that came from 42 countries. There are many thousands of alumni of this competition. So this is a worldwide endeavor, and people are very excited to participate in synthetic biology. So these are, the competition has expanded from just being focused on undergrads to having postgrad and high school competitions. But the bread and butter is still undergrads. So a little flavor of the world of synthetic biology and what changes are already here and are coming, but what are the implications of this? So when it comes to deliberate misuse or using biological organisms for a potential weapon, there's so many possibilities. So it's not, synthetic biology adds to the risks, but it does not take over the risks. There are still lots of pathogens out in the world that could cause harm, and they're already perfectly designed for that. And they do that every day and make lots of people sick all the time, all over the world. But what synthetic biology does to change the risks is it allows you to skip the step of first getting your hands on a pathogen. Because using some of the tools of synthetic biology, you're able to create a virus from scratch, mostly viruses are small enough to do this now. So you don't require the access to the pathogen. And this is a problem because in the US, a lot of our security for pathogens is based on access control. So if it's all about trying to prevent a person who is going to misuse the work from actually getting your hands on anthrax, for example, or Ebola, whereas using synthetic biology techniques, you might be able to synthesize Ebola. And this is just getting a little old now. This is from 7 years ago. We looked for an almost 2-year period to see which pathogens that the US regulates where they're found in the world, just to make the point that what they call select agent pathogens are causing disease all the time. So synthetic biology and new emerging biosciences might be adding to the problem, but these pathogens are out there in the world. These are not, yes, these are where they're causing disease. So most of this was from ProMed, where they were actual. So the actual incidence of disease is probably much higher, but we were just relying on a few different sources of reported cases of disease. Yeah, not laboratory stocks. So the worry is that not all these pathogens are able to be found in the world. So synthetic biology may give you a shortcut to getting your hands on some of these pathogens, but there are some pathogens that are not so easy to find in the world, and one of them is smallpox, the virus that was eradicated and declared eradicated in 1980. But still in the 20th century caused more, the century it was eradicated, it caused more deaths than all wars combined. So it was a devastating and terrible disease. It was sequenced in the mid-90s, and you might recognize a couple names on there on that paper. And the sequence for smallpox is found on the internet, and it's been there for a long time. So this is the coding for smallpox is available, and this is a known virus that causes disease. So it's no modifications necessary. And the World Health Organization sounded the alarm in 2010. 7 years later, the technologies to be able to create this are more available, and accuracy would be greater. So this is a concern. Another concern that's been highlighted for synthetic biology is the potential to do something that is not found in nature. There was an article in The Atlantic 2012 about using synthetic biology and other biotechnologies to create a virus that was specific for one person, so an assassination weapon. And so it's interesting. It was meant to be very provocative. It was very provocative. 5 years later, it's still being talked about. But some of the things that and this was pre-CRISPR, a number of scientists contributed to this article or to the ideas behind this article. Just some things to keep in mind. This is, while a variety of people think it's possible, it's important to think about who might be doing that and the difficulty that they would have to be able to produce a virus that that would be very difficult to test and would be, well, it says something about the actor of somebody who would invest in the resources to produce something like that. And that this should not be considered necessarily a DIY bio threat, pulling DNA out of strawberries. So what can be done to diminish these security risks? I mean, the first thing, unfortunately, is that you cannot categorically prevent biological weapons development and use for a variety of reasons. And there's a lot of debate. Why haven't we seen more of this? And we can talk about that. But as far as availability of the knowledge and material, you cannot prevent it entirely. And that's part of the reason why it makes norms so important. We do have a biological weapons convention. There is the UN Security Council Resolution 1540. There are a lot of, we can talk about some of the challenges with these international treaties, but at the end of the day, it's very, very notable that there is no country that openly brags about their biological weapons capability or their desire to have one, which is not the case with other weapons of mass destruction. So there are other things that can be done to diminish security risks. So there are companies that do gene synthesis. That's what they do, and people buy tracks of DNA. It's a lot easier to have a company that's expert in doing that do that versus having to invest in the equipment and do that yourself. So they screen their orders to make sure people aren't ordering smallpox from them. Not all companies do that, but there is an association of companies that are international that do screen their orders. And so there's a lot there's some investment now in helping to make screening easier so that they can screen for they have a more refined database to screen against. But there's more that can be done, in my opinion, to increase the number of companies that do screening and to give them opportunities to report when they get a bad order or a problematic order. And there's ways to support the companies in their screening, which is voluntary. There's a lot of work that can be done to engage with the community of practitioners. A variety of groups have engaged DIY bio labs and community laboratories. We've got one in Baltimore called BUGS, Baltimore Underground Science Space. You've got one that's close here. There are DIY bio labs all over the world and DIY bio communities. So there's a lot that can be done to reach out to these people. And most of this is educational. It's fun. That people can learn things about their own health and just trying to give a social network for these people so that that they can be well informed and so that they have some place to go if there's a problem. I'm recently concerned about whether U.S. scientists are going to enough conferences in the world that they would be able to have a better sense of what is being done by other researchers from other nations and from other fields. And this is something, a potential security risk going forward. And I'm going to talk a little bit about the dual-use research issue. But at the end of the day, because you can't categorically prevent BW development and use, you have to be ready to respond and to do early detection and to invest in public health. That's really the end of the day what has to happen. So the dual-use research issue, I separate out a little bit from the other security risks because it's a conundrum, it's a challenge all of itself. So there have been legitimate scientific research papers and efforts that have raised security concerns because they lower the barriers to biological weapons development. They make things, they uncover information that could be used potentially in a biological weapon. And every few years, there seems to be another one that really captures the imagination of the biosecurity community. And, but it's a challenge because this is legitimate research that's being done for other purposes, often medical reasons or public health reasons. And these are just three, but I could add a lot more to this list. Following one of the papers that was with mousepox, some researchers had put in an immunomodulator into mousepox, and they found that the virus could evade the vaccine, which is problematic if you think that mousepox is a close cousin of smallpox. So the worry is that if you did the same thing to smallpox, then maybe a modified virus could evade that vaccine. So a group came up with, convened by the national academies, came up with a list of potentially problematic areas of research that could be done for legitimate purposes, but yet might lower the barriers to biological weapons development. And so if you're going to do one of these things, you should be prepared there only is a concern regulatory-wise if you're doing something with a select agent and have one of these activities, but the public relations fallout can happen with any of these activities and any other type of research. So dual-use research of concern is a defined thing where you have particular dual-use research that is immediately applicable to weapons development, and so this is something that there are guidelines in the U.S. Health and Human Services for, but the problem is that not everyone sees the risks of this research the same way, and so it's hard to do something about it. Understanding who might misuse the research is a challenge. Understanding whether getting to a point where people agree on what the benefits of the research are is a challenge. And after 10 plus years of going through one dual-use research of concern article after another, I think my main conclusion is that consensus is going to just, it's just not going to happen. So to prove this, we did a study a Delphi study. If you're familiar with the Delphi methodology, it's a way that you can get consensus and people can understand other positions and have the opportunity to change their mind. So what we did is we asked 59 US biosecurity experts a series of questions. They answered those questions. All the other experts could read the answers to those questions. And then they had an opportunity, without knowing the identity of the person who wrote it, and they had the opportunity to change their mind in response to the question. And then we go through these cycles until you get either a consensus or people's answers don't change. And so what we found is that we only needed 2 rounds because nobody changed their general. And we were trying to get at, because in the bio realm, there is not a long history of incidents. So you don't have the history of, well, we've studied 1,000 bioterrorist attacks, and in 20% of them, this is what happened. You don't have that, which is good. You also don't have have not had a history of rock-solid intelligence when it comes to these matters either. There have been errors on one side and the other, for example, thinking that the Soviet Union did not have a biological weapons program when they had a very developed one, and then in the case in Iraq and the second Gulf War. So to show you one of the answers to this, we asked the group what they considered the likelihood of a bioterrorist attack anywhere in the world that would affect 100 people, which is, I mean, a very small number. I mean, more people are often affected by you know, bad potato salad at a big picnic gathering. And anywhere in the world, they didn't necessarily have to die. And where did they think that would happen, whether they thought that would happen in the next 10 years? And we got answers from 0 to 100% with a mean around the middle. So there's no agreement among people who know a lot about these issues. So, I mean, if it seems like biosecurity policy is a little bit all over the place, it's because not everybody sees the risks the same way. And they don't, and this extends to who they think is likely to be the problem. So we asked people whether they thought that there would be an attack that would emanate from a nation state or an individual or a non-state actor. And I mean, the same reasons were offered for beliefs on both sides. People who thought that we were more likely to see a bioterrorist attack said, well, you know, pathogens are so easy to find, you know, anybody can get them, and the knowledge is everywhere. And, you know, and look at what happened with Ebola. I mean, you know, that's going to be inspiring to them. On the other hand, people who thought that it was going to be a nation state, and these are people who some of these people were have governmental responsibilities for these issues. They thought, well, it's really hard to acquire pathogens, and it's just really hard to make a weapon. So, I mean, it's very confusing. So that's why I think that consensus on some of these legitimate science questions is going to remain challenging into the future. So safety is something that I've been much more encouraged about, because safety is something that you can talk about and you can measure a little bit better than the security realm. There have been no incidents to date with synthetic biology and safety, but there are some reasons to be a little concerned about. The DIY community and iGEMers, these are relative amateurs, so people worry about the potential experience level and if they get in over their heads and what they could do without meaning to. There's a whole concern of some of the applications for synthetic biology. Like if you're going to use a synthetic organism to do mining, well, it's got to be near the mines. So it can't be in a traditional containment in the laboratory. It has to be out in the world. So how do you contain something and yet have it be outside? So this is a challenge. And then there's this general uneasiness that, like, oh, it's getting really, these technologies are really powerful, and what could happen by accident? So what in particular I've been concerned about is the potential for something to happen and become a contagious incident, and then that it could spread beyond the people involved. I mean, there are laboratory accidents that happen all the time, unfortunately. Usually they are most affecting to the people who are handling the pathogens of concern. It has not happened where you've had a worldwide epidemic touched off through mishandling contagious pathogens, but there were some close calls with SARS in 2003, and that was not a modified SARS, it was just straight up SARS that is very contagious, and there were some incidents where people brought their work, unfortunately, home with them. And so the worry is that FEIC is a World Health Organization term, a public health emergency of international concern. And so you worry that a laboratory accident could end up being a more general problem. There is a lot of concern, another dual-use research of concern case with gain-of-function influenza. If you don't know what this is, you're so lucky. because there were many hundreds of hours that were spent in meetings talking about what should be done in this area, because these two groups of researchers, they were interested in whether H5N1 avian influenza was likely to go pandemic. Could it evolve to be transmissible between mammals? And so they decided to test this in the laboratory, and they found that, yes, it could be transmissible to mammals, and so the idea is that we should be more concerned about the potential natural evolution of H5N1. But when they published, or just before they were about to publish this, it became more generally a concern for security reasons, because if somebody were to take this, they could create a weapon, but also because of just safety risks. What if people were doing this kind of experiment and they didn't have the safety experience in working with highly contagious diseases, and they could touch off a pandemic. So what can we do about this? Safety is just relatively neglected as an area of science. People want to do research. They don't want to do research on biosafety. Biosafety officers do not get the respect that they often, they are, with the Select Agent Program, they have a much stronger role in those laboratories than they did in the past. But traditionally, biosafety has not been paid as much attention to as other areas. And there's a lot of data gaps. We have no idea how many accidents typically occur. We don't have any idea whether there are common areas of missed, near misses that we should be paying attention to. There's no funding for biosafety. There's nobody getting a master's degree in biosafety to do some of this work. And I have a list of some of the areas where we need more information. There has been finally some work done with intrinsic biosafety, so trying to get at the problem of when you have a synthetic organism that's in a new spot, how can you design safety mechanisms within that organism so it doesn't spread outside of where you want it? And that's much more possible using synthetic biology. And also training. Biosafety training is, we have the BMBL, but maybe there should be a more updated, more intuitive way so that you can reach these DIY bio people in a more fun and interesting way than through the way that we all were taught. And here's some of the list of some areas where really there's so many master's degrees, or PhD dissertations that could be focused on some of the filling in these data gaps, but there are no programs like that to address them. Everything from behavioral studies, like how do you keep people aware of the risks of when they're doing the same kind of monotonous, tedious thing every day, but it just happens that it's Ebola that's in the pipette, to keep them more aware that they, so that they don't injure themselves. Everything from that to how do you do inspections so that you can increase the safety of that inspection of the laboratory versus just dinging them off of a checklist, which has been a frequent criticism of inspections done through the Select Agent Program. And then there's moving up a level to the national obligations for safety. We don't have a coordinated biosafety program in the U.S. that is, there are different centers of activity for biosafety, but we don't have somebody who is responsible for biosafety in the country. But so it's a little hard. We're not in a good position right now to be able to say like what you'd like to see in another country when it comes to biosafety versus our own. But what would you like to see if you hear that a potentially dangerous experiment is being done somewhere in the world? What would you like to see that country's investment in biosafety look like? What is our obligation to other nations for our safety program and their safety program? So the final topic we want to talk about is U.S. competitiveness. Synthetic biology is, as I said, a relatively young field, and it came from the U.S. and most of the investment is still in the U.S. But there are nations that are seeing this as a way to boost their economies in the future, and so there's a lot of investment around the world, particularly in the UK, China, and India is catching up. BGI, Beijing Genomics Institute, now does more sequencing than all of the US and I think half of Europe. So they have more capacity to do sequencing. And they're moving into much more interesting areas of research as well. There's not as much barrier, there are not that many barriers to entrance. There's no need for natural resources, but there's a lot of capital, and drawing expertise can go a long way in boosting capabilities. This is inevitable that countries will want to be part of this, but this is happening at the same time that there are concerns about the erosion of capacity in the U.S. And the NIH has said that that our competitive position is decreasing. China is going to overtake the U.S. in R&D spending. And then this is my personal beef when it comes to that we're not doing enough to create a climate that's pro-biotechnology and pro taking advantage of some of these benefits in the future when you have a lot of misinformation about GMOs. People call synthetic biology genetic engineering on steroids, and there's some truth to that. It is genetic engineering, and it's more powerful than before. But when you have companies like Whole Foods and Chipotle, this is a big part of their marketing to be anti-GMO. It's not, well, it's not conducive to a good environment for biotechnology. And won't even get into the whole anti-vax stuff. Well, actually, I'd love to get into that, but it's not directly relevant. There was a report that came out of DOD saying that this is a concern, that DOD does not have enough expertise, and particularly in the among uniformed personnel. And so this inspired, I think, a couple of iGEM teams to be created, one from West Point. I don't know how they did. And then here's the most recent iGEM results. You'll notice that of the grand prize and all the award positions, that there are no U.S. teams that got in the top prizes. And this has actually been true for the last several years. It's been a rarity that a U.S. team has won. When I visited JBay yesterday, and I talked to somebody who said that, well, a lot of these teams have, it's a little bit like in a science fair where most, if the kid did it themselves, it looks a certain way and you can tell, and there's a lot of parental involvement. And he was saying that a lot of these teams have had a little bit of help. Nonetheless, it is the premier competition for this area, and there's no U.S. presence in the awards. So why does it matter that the U.S. is not on the leaderboard for iGEM? There are people who strongly believe that this is the way of manufacturing for the future. That this offers a distributed way to do manufacturing. It's that we're going to be able to, many products that we have can be made biologically. It's better for the environment. It could be more cost effective. This is an opportunity for this century that we may be not participating in if we do not have enough investment. But it's also important for our security. There are DoD applications that require synthetic biology, and it also is important for our security because if our economy is not benefited, that is tied into our security. But another aspect of this that I want to underline is the potential loss in governance of these technologies. A lot of these applications are not, it's not accurate to say it's in a Wild West, but they're not regulated, and they can't be regulated. When they're new ideas, and there are decisions that are made to invest in them or to invest in certain safety steps before they can be put out into the general population. So, for example, it is now, using CRISPR, you could potentially make edits to embryos so that you can remove hereditary diseases like beta thalassemia or Huntington's disease. So how are you going, the medical potential for this is amazing and wonderful, but what kinds of steps do you want to see? What kinds of safety checks, what kinds of boards or regulatory systems do you want to see evolve around that medical potential to address so that people who are in need of it can get it, but that you don't have the concerns that many people have about designer babies. Another example is gene drives. This is also using CRISPR so that you can have non-Mendelian inheritance, so you can spread a gene throughout a population. So people are talking about using this for mosquitoes to either make them resistant to malaria so that they can't spread it, or to just eradicate them by making the next generation of mosquitoes all male, for example. So that's pretty cool. Malaria is pretty awful, and Zika is a major concern. But what kind of safety checks do you want to see with these technologies? What kind of steps do you want to see them using, like testing this in a laboratory before it gets put out into the wild, so that it doesn't cause any other effects? If your scientists and your national academies are not involved in this process, they will not get a say in that governance. And there's no regulatory possibility for it until it becomes an established technology. In de-extinction, there are people working to bring back woolly mammoths and so forth. So what can we do? I recently wrote a memo to the new administration. This is kind of my wish list. And I'm sure that my encouraging foreign students who receive their PhDs in the US in technical areas should receive green cards. I'm sure that's going to be #1 on the list. But there are boosting competitiveness it's not rocket science. Stable funding, encouraging people to stay in the field, encouraging new educational opportunities, giving people, the iGEM teams, a space to work, and being able to give their potential mentors the ability to be good mentors by paying them to do so. And these are ways that competitiveness issues can be addressed. There is a lot of back and forth over how we should regulate these areas. The U.S. has traditionally been focused on evaluating the product of a biotechnology and not the process made to make that product. So the European way is to use the precautionary principle, so that the idea sounds great. It's like looking before you leap, but in practice, this is often stifled innovation, and so. Adhering to a product-based method of regulation has worked well in the past and should be continued into the future. There's at the same point, there are areas of synthetic biology that need to be more closely regulated. Our regulatory system in this area is quite old. There was an attempt to update it in the last administration, but I don't know if they completed that task, and certainly they didn't do the big overhaul that might be needed so that things are actually appropriately regulated. There was you may have heard about, there was a Kickstarter campaign for making glowing plants, and there is no regulatory framework that fit into, and a lot of people thought that if you're going to have plants that would glow and anybody could plant them wherever, that maybe that's something that should fall under some regulation somewhere. And it turns out that it was a moot point because they never got the plants to glow. And they still haven't sent anything to their investors, and they're working on patchouli scented moss, according to their website. So in case that's a product that you desire, you should look into it. But at the end of the day, you need to support science and scientists so that these, whether it's synthetic biology or whatever the next iteration of genetic engineering or DNA recombinant technology is, so that can be something that we can all benefit from. So thank you very much.